Welcome, friends, to the series of learning containers and Kubernetes. So, in the previous lectures, we have created the GKE cluster in Google Cloud Platform. Also, we have created number of Kubernetes clusters in different environments like on-premises systems, like AWS EKS environment. Also, we have created managed container services like Google Cloud Run or ECS Fargate. So now we are going to monitor those Kubernetes clusters. Doesn't matter where your cluster is actually, doesn't matter whether it's on cloud platform or whether it is on premises system, but we are going to have some open source monitoring tool installed on the GKE cluster so that we can monitor our clusters in different ways, like how our nodes are behaving, how our pods are behaving, how the different deployments are behaving, what are the CPU consumptions on node level or the CPU consumptions on pod level. So macro level or micro level, we can monitor the clusters, GKE clusters or Kubernetes clusters or AKS clusters or EKS clusters. So we can uh, monitor any kind of Kubernetes clusters using these Prometheus and Grafana. So Prometheus is the tool through which we can actually monitor the Kubernetes and its components. So in this particular lecture, we will try to install the Prometheus, and the Prometheus will actually extract or generate logs on the clusters, and the Grafana is the other visualization tool which can be integrated with this Prometheus so that we can graphically using different dashboards to visualize our environments. So friends, this is our Prometheus architecture. So we need to a little bit understand what goes beyond the screen. So if you can see this Prometheus server, we are having three components over there. One is TSDB, so that is a database where our metrics logs are there recorded. And we are having a metrics retrieval process that actually retrieve the metrics from different environments. So we then, the Prometheus servers then use this TSDB, the database, where actually it stores the matrices after retrieval from different environments. So we can see that we can get the discovery targets on Kubernetes and console or file SD. So these are all service discovery from where these targets Prometheus actually collect the metrics, and as well as it is having the node exporters, and uh, it is having the slash metrics. So these apps having these metrics have these tags with slash metrics, collects the data, collects the metrics from these apps through this metrics process. So once this TSDB got these data, we are having this HTTP server through which we can actually access the Prometheus from browser. So there we can interact with these TSDB, and we can visualize these things through this Prometheus web environment. Now we have the push alerts. So there is an alert manager where these alerts are pushed. So basically, whenever there is some problem happens, if some metrics is made the target, then probably at that moment you have just set up the alerts through this alert manager, and at that time these alerts will be pushed to this alert manager, and the alerting service will then be subscribed with Slack or email or X Matters, etc., etc. So the alert manager is something which can actually deliver the alerts to different channels, and this alert manager is being triggered through these push alert triggers from these Prometheus server. There is a PromQL, which is basically the query language, which actually helps to query different matrices, and it can be pushed to Grafana, or we can use the Prometheus web UI and the different API services as well, through which we can interact with these Prometheus servers through PromQL. So this is the query language which actually used in the Prometheus web UI or Grafana or different Prometheus APIs to retrieve the logs or retrieve the metrics data, either showcase to some visualized dashboard or some logs or through some programmatic way. And as well as there is a push gateway through which the batch workload is being can send the data to Prometheus servers as well. So this is the overall architecture of Prometheus. So the main thing is at the central, where we are having these Prometheus servers, having this TSDB component, which is the database holding all the matrices. And this matrix retrieval process sends the data to TSDB after receiving the data from different targets and different exporters. So after then, this database can be queried to PromQL, or it can send the data through some push alert mechanism. And through this alert manager, we can send the alert logs to different channels or through some ticketing tool. All right. So this is our overall Prometheus architecture. Now let's move on how we can install this Prometheus and how we can use these Prometheus to capture the different matrices. So let's go to the console. All right, friends. So this is our Google Cloud Web Console, and we're in the Kubernetes cluster dashboard. So right now we are having one cluster. So that is my GKE cluster. And if we can see, this GKE cluster is located as US Central 1C. Let us go to this cluster and let's see what are there. So we are having a zonal cluster, and this zonal cluster is actually located at US Central 1C as the control plane zone, and it is having the default node zone distributed in US Central 1 A, B, C zones. So all these zones are on US Central 1. Okay, and we are having only three nodes right now, and it is having these automatic pod auto scaling, and also we are having node auto provisioning. So that's why, I mean, whenever there is a demand of more pod to be created, it can automatically allocate those pods to the auto scaling feature, as well as if the pod needs more resources, it can vertically scale that pod as well. And whenever more pods are required and we do not have the capability in the nodes where we can provision the pods, it is having the node auto provisioning, so that the node will be added in the node pool as well. And this is how it can grow. So anyway, we are not going deep into this. So this cluster was created in the earlier lecture, and we are highly recommending you to see the lecture where we have created these node pool cluster, GKE cluster, and everything in a detailed way. We went through a long video where we have covered all the details, all the micro level details, what are there to create Kubernetes cluster in GKE platform. So please watch that video, and we are highly recommending you to watch the video so that you can have the detailed concept on GKE. Now, our main aim in this particular video is not GKE. Now, we are going to install the Prometheus on this GKE environment, but the way it is going to be created is exactly same in any environment. So even you are having the on-premises systems where the Kubernetes is installed, you can use the same way to install the Prometheus on your Kubernetes platform. So basically, what we will do, we will actually connect to this GKE cluster, and there we are going to install the Prometheus. So basically, it doesn't matter where your cluster is hosted. Basically, the main aim of creating the Prometheus server will remain same. So for now, we are going to connect this GKE cluster. So I'm just going to grab this command to connect to this particular cluster. So I'm just connected in the Cloud Shell. So let me paste the gcloud container cluster command to connect to this cluster endpoint. So, okay, we have connected to the cluster. Let's see what are there in the cluster. So basically, we did not do anything. So let's see get all. We don't have anything other than the default Kubernetes services. So practically, our Kubernetes cluster is having no load right now. No workload is there. All right. So now let's do something to create the Prometheus server. So let's go to Google and let's use this search in the Google search engine, which is Helm, Prometheus, GitHub. So basically, there are a number of ways you can create your Prometheus. So one of the easiest way is to do it through Helm chart. So Helm basically a repository, and it is best suited for the Kubernetes. So whenever there is some packages needs to be installed, Helm is the best way to install through Kubernetes. We are having the Helm community, and through this Helm community, they are building different kind of things so that it can be installed in Kubernetes in a very easy way. So similarly, the Prometheus is also can be installed. This Prometheus can also be installed through Helm charts. So this Prometheus community build this Helm chart, and the very first link goes to this GitHub repository for this Helm chart, where it is actually going to install the Prometheus. Now, if you go to these charts, you will see different elements can be installed through Helm charts. So we are interested with Prometheus. So just look for Prometheus, and there, if you go inside the Prometheus, you can see the details how we can install this repository in our Kubernetes environment. So exactly what we will do, we will just copy this thing, and we are going to run this in our cluster. So it is going to add the Prometheus community repository, which is a Helm chart. This is the GitHub repository page. What exactly we're going to add right now. Now, once it is done, we are going to update our repository, and it will install the repository. It will successfully got updated. So now we are going to install this Prometheus. So I'm just going to use the name. I mean, there is no need to give some other names. I mean, you can definitely give other names, but I mean, for sake of simplicity, I'm just going to give the name as Prometheus. And then you can give this Prometheus community / Prometheus so that it will start installing this Prometheus in the environment. So it will take some time. And once it is done, the Prometheus will be installed on the Kubernetes cluster. All right, friends. So after a minute or so, the Prometheus got installed, and you can see the namespace it has chosen as default. Maybe we could probably give a good namespace, but still, I mean, it's fine. We're absolutely fine because it's just a demo. So the default namespace, and it is saying that it has deployed revision 1, and it has also given the commands how we can actually expose these ports. But actually, this is saying that we can export the port. So I don't think that this is a good way to expose the port, because port can die. It's better to go with the services. So first and foremost thing we can check like what are there created under the hood. So if we say kubectl get all, we can see couple of things has been created for this Prometheus. So let's see one by one. So we can see that it created couple of pods, okay, and it created couple of services as well. So first go with services. So you can see this Kubernetes service was already there as it was default one. But from here, Prometheus Prometheus Alert Manager headless, Prometheus queues state metrics, Prometheus node exporter, Prometheus push gateway, and Prometheus server got created. So these services are created, and you can see corresponding pods also running. So, for example, if you say node exporter, there are two pods are running, three pods are running actually for Prometheus push gateway, we are having one. For Prometheus server, we are also having one. So it is in container creating phase. So very soon it will be running as well. And as well as we have one daemon set, also we have couple of deployments. So this is very important. Like you can say like Prometheus server, Prometheus push gateway, and queue state matrix. So there are three deployment was created. So when we actually run the hem chart, so under the hood, it actually have all these things. So it created deployment and services, replica set. So all these things, it automatically created. So we can wait for a minute or so until these pods are completely in a running state. So it's fine that we are having the node exporters are running, and I think our Prometheus service is being created as well. All right, so we can see that all the pods are right now running, and we can see this Prometheus server service is basically a cluster IP service. So we can't access this particular service from our external world. So what we're going to do, we're going to expose this service uh, so that we can access it from the internet. So let me do that. So what we will do, we will say kubectl expose this service, and we can say load balancer as the type of this service. It's not a cluster IP or node port, and we can say target port is 9090 because that's the container port for the Prometheus server. And we can give it a name like Prometheus EXT so that this service can be exposed to the external world. So if we go back and check these get all. So we can see right now we are having these Prometheus external services being created, and there is one uh, external IP that is being created right now. So let's wait for some time, and within a minute or so, we will get one external IP. Now, if you see this load balancer is basically has been created over, so if you just take the load balancer, you can able to see that one load balancer is created for these Kubernetes service. And so this is the load balancer that is being created by these Kubernetes. And for this load balancer, we're just waiting for get the external IP address. And now we got the external IP address. Now, if we go ahead and check the external IP address, we can see the Prometheus will come. So we can say continue to this side because it's a HTTP service. And we can see the Prometheus is coming. It's a time series collection. So voila, we just got this Prometheus action. So over here, we can enable the history. We can enable as use local time. And we can say like node underscore maybe we can say CPU seconds in total, and we can execute. We can see the logs are coming. We can see the graphs. We can see some graphs are coming as well. All right. So we are having all these things. So as well as we can uh, deploy our one pod, and we can see how it looks like. So maybe we can say you um, maybe we can check some replica set or pod container info and can execute. We can see we are having one pod is running, and we can have this table as well, where all these logs are being captured. Right now, you can see these Prometheus node exporter. It's itself is showing this image. Now, um, if we really expose one of our favorite my app over there, let's control C, and we can we have one created my DB, and we got the IP address. So this is the private IP. We're just going to grab over there, and we can go ahead and deploy our favorite my app with these configuration. Let's see, we can create one deployment dot YAML. We can say y deployment dot YAML, and we can we can use our Learning Light My App version 1.1, where we have provided this MyDB private IP address, and we can save and we can deploy this particular um, YAML, and we can check uh, our My App service got created right now. It's just, having this container, creating the containers. And once the container will be created, we can check whether this application can be accessible from the Kubernetes. And then we can see how Prometheus can see this Kubernetes service. So let's wait for some time. Yes, it's just running right now, one pod. And also we got one external IP address. Let's check the external IP address for accessing our favorite My app. We can see we can see our Streamlit application is just coming up. And yes, I think we can see our version ready. We can see our application is ready, and we can say hello, and we can insert the item. This actually inserted the item into this Cloud SQL database. We can query it, and we can see that it's exactly running fine. Now, if we go ahead and check the a Prometheus service, and we can see our my app uh, container is actually being shown over here. We can see that this container is running, and certainly we can see everything is being logged in our system through Prometheus. So that's excellent. We can check that this is our um, pods, and we can able to log our new application through our Prometheus web UI. So the Prometheus is excellent for capturing all the matrices, but the problem is with Prometheus that it cannot show very good information about uh, information of graphs. So you can see that there is a spike we can see due to this new pod that we have deployed. But the problem is that it cannot show a good graph. So that is why we will install the Grafana on top of Prometheus so that the matrices that it captures beautifully, it can it can be shown in the very visual graphical way through Grafana. So that is what we will do in the next lecture. So in this lecture, we saw how we can install the Prometheus on our Kubernetes service. And this Kubernetes service is basically running this Prometheus on the same Kubernetes cluster in the same node pool. But definitely you can have this Prometheus service installed in a separate node pool on the cluster so that the cluster can have a set of nodes for these dedicated Prometheus capture the metrics of your Kubernetes system. So this is our Kubernetes engine and where we have installed the Prometheus. So this is our Prometheus dashboard and we saw how Prometheus was actually capturing the matrices from our Kubernetes cluster. But unfortunately, Prometheus is not showing different graphs, or it is not having so much powerful visual dashboards through which we can have our Kubernetes monitoring, but it can produce or it can collect excellent metrics logs from which we can understand what's going on behind the scene. So here our Grafana comes in the picture, which we can install on top of Prometheus. So basically what Grafana will do, Grafana will actually collect all these data from Prometheus data source and it will show the visuals in different dashboards. So in this particular lecture, we will actually install the Grafana on our Kubernetes cluster. So our Kubernetes cluster, so our Kubernetes is actually running a couple of Prometheus features like Prometheus node exporters and Prometheus alert manager and Prometheus server itself. So we are going to install Grafana on top of this. So we are to install the Grafana on the same Kubernetes cluster. And let us see, apart from these, we also we can check the workload in our Kubernetes engine, and we can see our My App, our favorite application was also running on the same Kubernetes cluster, apart from all these Prometheus items. And we can see this particular My App deployment was having one service. So you can have check our services for My App, which is basically running this actually Streamlit application, where we can see our application is running and this is actually working as expected in the same Kubernetes cluster. And we are supposed to monitor this My App application through our Grafana dashboard along with other matrices like how our actual Kubernetes is actually performing. So let's get started. So first and foremost thing what we're going to do, we're going to search in Google Helm Grafana GitHub. And that will give us this link, the very first link, which will redirect to our Grafana GitHub page. And over there, if you go inside the charts and if you check the Grafana, we are having one Grafana folder, and inside that we are having the detailed instruction how we can install the Grafana inside our Kubernetes engine. So what we will do, we will grab these commands and we'll run them in our Kubernetes cluster. So let's do one thing. Let's grab the repo add command and let us go to our Cloud Shell to have this on our Kubernetes cluster. So repository is added, and then we are going to um, update the repo. All right, so our repo is updated, and next is just install, and we will say Grafana to install the Grafana. So let's use this command as well. So once this installation will be done, we will see our pod for Grafana and services for Grafana will be created. And definitely, it's just like the Prometheus. The Grafana service that will be created as a cluster IP. So the next part will be to expose the service Grafana. So you can see that Grafana service has just got created, and you can see we have one Grafana pod running. So currently it's running, and we are ready to expose these Grafana service to some load balancer so that we can use that in from the internet. So what we will do, we'll go to this tab, and yeah, I think you can check that we already have the output that our Grafana is installed for. Absolutely fine. Now there is one thing we need to notice, like the admin password needs to be checked through this command, because when we access the Grafana from web browser, we need to provide the password of admin. So that's what we need to do. But before that, let us expose the service as a load balancer, and the target port is 3000. You can see the 3000 is the Grafana target port, and we're going to name this as Grafana EXT so that the service will be exposed. So let's go back to this tab where we are actually monitoring this Kubernetes get all. So we can see that our Grafana extension load balancer service has been created, and right now the external IP is being provisioned. So we will wait for some time so that our external IP will be created for us. And once it is done, we will access the Grafana from our browser. So let's wait for some time till this external IP is being provisioned, and it is provisioned right now. So what we will do, we will go to this dashboard, we will go to this browser, and we will type our so the Grafana screen is loading, and within a second or so, login page will be landed where we need to provide the admin user ID and password. So we know the user ID is admin, but we don't know about the password. So the password needs to be fetched from the secret. So uh, this is what we are going to do next. All right, so our Grafana login page is landed, and now we need to provide the password of this admin. So let's go back to the screen, and let's go back to this tab where we have seen this particular command where we said how we can fetch the password. So I'm just going to paste the same thing, and let's see we got this admin password. So this is how we can get your admin password for Grafana. So let us paste this password over here, and you can see we are logged in. So this Grafana dashboard is being logged. Now, what we need to do, the first thing we need to check these, we need to add these data source. So for this data source, we are going to use Prometheus because Prometheus we have already installed in these Kubernetes for fetching the metrics data. And over here, we need to provide the data source as the Prometheus so that the logs will be visualized through Grafana dashboard. So what we will do, um, we will provide this IP address, which is our Prometheus URL. So we will do just save or save and test, and you will see whether this Prometheus is accessible or not. So it says that it is accessible. So we have done adding Prometheus as the data source for this Grafana dashboard. Now, the next thing we need to do, we need to go to this dashboard and we need to create one dashboard. Now, we can create the dashboard manually by providing all these visualization data. So that is one option. You can, if you are an expert, then probably you can add the details visualization for your Grafana dashboard. Other very interesting point that I want to show right now, because Grafana has a library of many dashboards. So if we go to our Grafana web page, we can see that there are lots of uh, dashboards are already pre-configured. We can either download the JSON file or we can use the ID of these dashboard. So this particular dashboard is for Kubernetes cluster Prometheus, specifically for Prometheus. There is another dashboard for node exporter. So basically, I will just go ahead and add this Grafana dashboard where we can check these Kubernetes cluster. So what we will do, we will just copy this dashboard ID and we will actually uh, import the dashboard and we will provide the ID over here. And you can say load. And once it is done, we can use this Prometheus data source and we can import. So it is importing the dashboard and you can see the visualization has been come already. So we can see our deployment replicas, deployment replica update and all those stuff. We can see we are having 3 nodes, 46 pods are running right now. There are 7 pending and containers are running like 68. So all these things are coming. I mean, the data already started to come. There is another dashboard which you can see for the node node exporter. So basically, if we are interested to check how our Kubernetes cluster node is actually doing, we can use this dashboard. So let's copy the ID of the dashboard and we can go to this dashboard and import this dashboard over here. Um, we can load this dashboard and we can keep Prometheus as our the same Prometheus metrics we are just going to import as a data source. So it started to import the dashboard and it will show the visualization in front of you where it will show how our entire node is actually looking like. So you can see we are having CPU, memory, disk, everything. So even we can go ahead and check, explore, so that it will be showing the detailed configuration of our detailed metrics of our nodes. We can go to these explore metrics and we can check the memory and all those stuffs over there. We can see the details, metrics, and as well as we can uh, check the breakdown. And there we can see lots of stuffs are there. So if we are interested to change the timing like last 5 minutes or so, we can have better visualizations. So all these things we can do, and also we can add, we can customize our dashboard as well. We can provide the other metrics. If we know these Grafana um, query language, we can change the metrics and accordingly we can see the metrics details as a graph. So that is a very interesting dashboard for specifically if you are interested about CPU memory swap space. That is the uh, page space basically that is going to be used after the memory is completely utilized. So it's better to not having any swap space used. So all these things we can check from the node level. We are having the detailed section for memory, CPU, and the other sections like memory stack, disk space used, and you can check the different uh, file system. Those are actually in the node. So all these things we can actually check from these node exporter dashboard. There is another interesting dashboard you are having in Grafana that is specifically for these Kubernetes pods. So we are going to copy this dashboard ID and we are going to uh, we are going to we're going to import the dashboard once again for these pod macro level monitoring. Check these provide these data source as Prometheus, and let's import this dashboard. Over here, you can see it's a very interesting dashboard. You can see what are the containers are running, total CPU memory, and how the CPU usage by container. So you can see these are the containers. So if you are interested about our My app, which is basically running our actual application on this Kubernetes cluster, we can see that my app, how it is actually uh, behaving, how much CPU is used by this container itself. Also, we can check the memory used by this particular my app inside our container uh, inside our Kubernetes cluster. We can check the network packets, and all these things are very much pod level. We can change the namespace as well. Unfortunately, we are having everything on our default namespace. So these are all the things we can check from our Grafana dashboard. So we can see our memory used by my app is 174.19 MB. So we can check all the details from here, and that's excellent dashboard I can ever seen in Grafana. So all these things are really important, and you can check from Grafana with these excellent visualization. So that's it for today, folks. So we have learned how we can install the Grafana on top of Prometheus. We can use the Prometheus as the data source of Grafana, and how we can visualize all these dashboards. Those are actually pre-configured in Grafana Lab, and we can use them and we can import them in our system to monitor the different pods and different services and different deployments in Grafana, in our Kubernetes cluster to Grafana. Thank you for watching this video. In the next video, we will go deep inside the Kubernetes environment and we will learn more about these monitoring matrices. Thanks for watching this video. We will see you in the next video. Till then, thank you. Goodbye. Take care.